Thank you everyone for joining us today as we take you on a technical deep dive for Amazon EC2 Fleet. My name is Boyd McGeeky. I'm a Senior Product Manager here for AWS, and I'm lucky enough today to be joined by Chad Smutzer, a Specialist Solution Architect. So the agenda for today is to first take you through the motivation for EC2 Fleet. Why did we build the product? Then we'll take you through some of the common use cases that we're seeing customers leverage EC2 Fleet for. Finally, we'll go through the core features and the key benefits of EC2 Fleet before Chad takes over and takes us through EC2 Fleet in action and does a real demo around the use cases we'll discuss today. At the end of the presentation, we'll do a live Q&A, but please do not hesitate in sending through your questions. We've got a team here that will be answering your questions throughout the webinar, so don't hesitate. We'll just answer some of the more common questions and those that we haven't gotten to at the end of the presentation today. Let's jump in. So what was the motivation for EC2 Fleet? Well, to talk about the motivation, I need to take you through a little bit of history on EC2 instances and the pricing models for EC2. So when we launched EC2 well over a decade ago, there was just one instance type, the M1 Small. And our customers and almost certainly ourselves at the time knew that the M1 Small was not an instance that was going to work for every possible workload out there that used EC2 instances. And it was only a matter of a time before we added new instance types. And it wasn't long before we introduced two new options to EC2, the M1 Large and the M1 Extra Large. For all intents and purposes, these were pretty much the same as the M1 Small, just with more cores and more memory, more powerful versions of the M1 Small. Obviously instance types that are still available today, but hopefully not commonly being used because they are over a decade old at this stage. And so fast forward over 10 years of innovation on EC2, now we're launching instances like the P3 instance type, which is powered by Tesla Volta GPUs and was developed in response to customers really telling us that there's so much data in the world these days and increasing volumes of data that's being made available that they need more powerful machines and more powerful GPUs in order to crunch through that data, to feed their AI, to feed their machine learning algorithms, to improve autonomous driving, and effectively, harness this data and really take advantage of it with new innovations. And so, P3 was born, an instance type that was up to 14 times faster for machine learning workloads than the previous generation, the P2. And so we've obviously been innovating very hard. Another example of a more recent instance that we launched is the F1. The F1 instance type was the first instance type that EC2 offered with a field programmable gate array. And so the F1 has up to 8 FPGAs per instance. And again, this was based on customers' feedback that while CPUs and GPUs were great, there were certain workloads that could really be accelerated or workloads that were otherwise impossible that could take advantage of FPGAs. And a good example here is Edico Genome, who was actually able to break a Guinness World Record for the fastest analysis of 1,000 genomes. And they obviously did that using the F1 instance type on EC2. So when we think about these instance types we're launching, I've obviously already mentioned it, but over 90% of the roadmap items for EC2 are born out of customer requests, and they're designed to meet very specific customer needs. And we've been doing that for, as I say, well and truly over a decade at this point. So while we started with one EC2 instance type, we're now at a point where there's well over 70 different instance types and options available for customers. And in just the last 18 months, there are many instance types. I won't bother listing them all. They're on the screen. I won't bore you by running through them. But obviously, there are many different instance types. And even today, I know that there are a few that I'm missing off from the last 18 months because they were so recently launched that I haven't yet gotten them up on the slide. So we've continued to add more instance types in response to customers' specific requirements and needs. But that doesn't mean that all customers have, incredibly specific instance needs. And a lot of customers will actually come to us and say, you know what, I need some CPU and memory. What's the best instance? Just tell me. There's so many different options. If you could just guide me, that'd be great, because I just want some cheap cores and memory. We'll pause on this instance history for just a minute and flip over to the history of the pricing models for EC2. So way back when we launched the M1 Small, there was just one pricing model for EC2 on-demand instances, And it was billed by the hour, which was game-changing, obviously, for people that were used to buying and renting servers with, multi-year commitments and huge capital outlays to do that. Hopefully, you're all aware that at this point, we bill on-demand instances per second. And on-demand instances are really great for, and have always been great for, achieving low cost with flexibility about the instances and how often you use them. It's great for workloads where you're just getting started, you're doing development, you're doing testing, and obviously great in an ongoing basis for workloads that are short-lived or spiky or highly unpredictable. But fast forward 2 years or about 2 years after we launched EC2, it was very obvious that there were workloads that were predictable, that didn't necessarily need to take advantage of the spiky nature or the spiky capabilities of EC2. And then we introduced EC2 Reserved Instance Pricing. Then, as today, EC2 Reserved Instance Pricing is really ideal for steady state committed usage. Usage where you know you're going to continue to use that instance and capacity for 1 to 3 years. In exchange for committing to continuing to use that instance for that term, AWS is able to actually give you an up to 75% discount over the price of on-demand. And then finally, those who have ever interacted with me before would know near and dear to my heart, not long after we launched reserved instances, we brought out Amazon EC2 spot pricing. Amazon EC2 spot pricing is low-cost compute, and the reason it is so low cost is it's because it's our unused capacity pools. It's up to 90% discount over the price of on-demand, and it's really ideal for workloads that are fault-tolerant and instance flexible. And customers will use spot instances to accelerate their workloads, to improve performance, or just save up to 90% if they have a workload that can leverage spot instances and they don't necessarily get any value out of additional compute capacity. So, hopefully you already knew this, but in case you didn't, hopefully by now you know that EC2 has a really wide variety of compute options and pricing models to serve your diverse computing needs. And so while most customers have told us that being able to select a specific instance and purchase model for their workload really matters, some customers have said that they want the flexibility to use multiple instances or multiple purchase models together. And so that's why I'm really excited to be talking here today about EC2 Fleet, an API that, with a single API call, you can provision capacity across multiple instance types and multiple purchase models to achieve your desired scale, performance, and cost profile. So with Amazon EC2 Fleet, we're focused on simplifying that provisioning process and giving you fast access to capacity, giving you the tools to balance or optimize across your price and availability needs. And then also, which we'll dive into in a little bit more detail, customize how you scale based on your application to allow you to scale in units that actually matter to your application. So let's go into some of the use cases for EC2 Fleet, some of the more common things that we've seen customers picking up and leveraging EC2 Fleet for, and really combining purchasing models and instance types into a single application. So almost certainly the most common reason we see customers attempting to combine business models is to turbo boost applications using spot instances. And the idea here is, depending on the nature of your application, you might be trying to get results faster, you might be trying to do 10 times more with the same budget, or you might just be trying to improve the performance of your application for your customers in a way that is not cost prohibitive, in a way that can continue to maintain your profitability. And so, here is an example of a real customer that runs a lot of big data analytics and data crunching workloads on AWS. And you can see they have a base of reserved instances. There is a certain amount of on-demand capacity that they use, but the vast majority of their usage and the most dynamic, scaling up and down component of all of their compute is spot instances. And so you can see that the idea here is that with EC2 Fleet, you can get started using on-demand instances or even RIs if you want, and then without any changes to your provisioning framework, you can just add some spot and turbo boost later. So it gives you that ability to get started using on-demand before you're ready to start turbo boosting and leveraging spot, knowing that when it comes time and when you're actually able to provision and leverage spot instances, you don't need to make any changes to how you go about it. A really cool customer example who's been able to do this is an organization called Get or Get Taxi. They're a ride-hailing service that runs on AWS, and they were able to save over $800,000 a year by taking advantage of spot instances. And really interestingly, because of how Get Taxi approached this challenge, they actually said, well, for every on-demand instance we no longer need, we're going to replace it with 2 spot instances. And so instead of saving 90%, they saved about 65% over the cost of running their service, but they're actually able to drastically improve performance because of that additional capacity that was available to allow people to match rapidly during peak load. And obviously that's given Get a great deal of confidence that they can add capacity super cost effectively whenever they need under peak load. Another use case for EC2 Fleet that maybe is a little bit less common is the desire to scale to truly huge volumes. Now, hopefully most of you know that when you come and request EC2 instances, it's normally a matter of seconds and then we start launching capacity for you. But some of you may be aware that if you wanted to go out and turn on 1 million concurrent vCPUs, we might not be able to satisfy that with a single instance in a single availability zone in a single region. And so customers are starting to use EC2 Fleet to achieve levels of scale that just are not possible or at least are more difficult when you use a single instance type. And so you might have seen some stories from different customers recently where they're scaling up to over 1 million concurrent vCPUs on spot. And one such example is Clemson University. Clemson University scaled to over 1 million concurrent vCPUs in a single region in a matter of just a couple of hours with no pre-warning. They didn't have to speak to Amazon and arrange anything special here. They were able to scale up, and while we did work closely with them, and anyone else that has a 1 million core run, please get in touch with your account manager. Anyone could take advantage of this scale today, leveraging EC2 Fleet. But if we look at the right-hand side of this picture here, you can actually see that they weren't able to achieve 1 million concurrent vCPUs from a single instance type. You know, they leveraged, they had Fleet and said Fleet is allowed to leverage up to 12 different instance types. And while the vast majority of capacity came from the C4 family, when that wasn't enough, they were able to automatically, without any intervention, spread and continue to scale. So you can use EC2 Fleet to achieve, previously unimaginable scale. Or you can also think of this as a way to sort of keep an on-demand backup. If your ideal instance isn't available, well, maybe we can launch your backup automatically. While that may be very infrequent, you might be a person that wants to always be prepared and always ensure that you're going to get capacity. And EC2 Fleet is obviously a great way to do that by having multiple instance types and being able to leverage the additional instance types only if we need them. And so I want to quickly help explain where the value of spreading across multiple instance types comes from for capacity. This is something that spot customers have been aware of for a long time, and something that on-demand customers don't really have to worry about. But it's something that if you want to go to 1 million concurrent cores is really worth knowing. So I just go through an example here of a region. Now, most people know that regions are made up of things called availability zones, which are clusters of data centers that are geographically redundant from one another, such that faults should only occur in one availability zone. So you're probably well aware the amount of capacity available in these different clusters of data centers is not going to be the same. Similarly, you're probably aware that C4 and M4 have very similar chipsets, but they're not identical. And the CPU to memory ratio between these instances is different. And so while it's very uncommon, if we were not to have sufficient C4 capacity to satisfy your needs, would it be okay if we leverage some M4 for a short period of time as we scaled up? The next level of detail here is that every size is also an independent capacity pool when it comes to how much spare capacity is available. And so what we're seeing customers do with EC2 Fleet is saying, well, I'm willing to use the C4 instance family, and I'm willing to use the 2XL, the 4XL, or the 8XL in order to achieve my scaling needs. Or you could even spread across families as we see here. But the general idea is, if you're just asking for one instance type, you're really just asking for this tiny slither of capacity in a region. And with EC2 Fleet, you can make a single request that actually spans multiple of these capacity pools, as many as 50 in a single request. And then finally, the other core reason we're seeing customers leverage EC2 Fleet is when they want to scale on units that truly matter to their application. When potentially the instance type doesn't matter as much to them, you might want the cheapest cores, the cheapest memory, or the cheapest way to run, 1,000 containers, whatever that may be. And so with EC2 Fleet, you can actually define a score for each instance type based on what your application actually scales on. So as an example, we might say, well, this instance, that's worth 4. These 3, they're all pretty similar size, so they're worth 2 to me. These tiny little ones, they're only worth 1 unit, and this big box here, it's worth 8. And then you're actually able to step back with EC2 Fleet and say, go get me 1,000. Go get me the equivalent of 1,000 units, and you can say, get it for me in the cheapest way. Or if you're using Spot, you can actually ask us to spread across multiple of these capacity pools to achieve your desired cost and availability using allocation strategies, which we'll come back to a little bit later on as we dive into the features of EC2 Fleet. But this allows you to actually step back and start requesting capacity in units that matter to you. So Univer is another example of an organization who's recently scaled to, I think, over 1.3 million concurrent vCPUs in a single region at the end of the day. As an organization, Univer is able to leverage EC2 Fleet to say, go get me cores. And go get me the cheapest cores available, and not have to worry about which specific instances they're using, knowing EC2 Fleet is going to go out and do that calculation on your behalf and get you the cheapest capacity based on the unit you scale on. As I say, when we get to the demo time, we're going to come back and we'll actually show you how you would configure an EC2 Fleet for each one of these different use cases. Now I want to take you through some of the core features and benefits of EC2 Fleet. So first and foremost, as we've just been discussing, the ability to define and scale your application in units that matter to you is one of the core features and benefits of EC2 Fleet. Once you set up your application to scale in these units, then you can stop worrying about instances and just continue to focus on what matters for your application. Second, massive scale. As we've been discussing, in a common use case for EC2, scaling up and down, day in, day out, there's absolutely no reason why you'd need to use multiple instance types. But if you want to go from 0 to 1 million concurrent vCPUs, the ability to leverage multiple instance types is going to make that a lot easier and a lot faster. And then finally, simplifying that provisioning across purchase models is something that a lot of customers have asked us for. That ability to just say, I want 100 units and 50 of them should come from Spot, a single API call, and we'll provision that on your behalf and deploy using allocation strategies. Which happily brings me to Fleet allocation strategies. We have allocation strategies for Spot and for on-demand, and based on how you're using EC2 Fleet, you might choose to use diversified for Spot and prioritized for on-demand. So we'll take you through all of those, but I just want to point out that 2 of these are very new. So if you've been using EC2 Fleet since it came out much earlier this year, do be aware we've recently launched 2 new allocation strategies that you can take advantage of. So for Spot, there's diversified and lowest price across N capacity pools. And then for on-demand, there's lowest price and new on-demand prioritized list. So what do these mean? So for the Spot allocation strategies, lowest N price is going to automatically deploy you across the N lowest price pools where you define N. So as an example, you might say, here's 5 different instances that I'm willing to use. I want EC2 Fleet to deploy my Spot instances across the 2 cheapest options from the 5 that I've provided. And EC2 Fleet's going to go out and try and evenly balance across those 2 capacity pools. This should be, for most customers, the way they provision spot instances with EC2 Fleet, because it allows you to balance your cost and availability needs. So what I mean as an example here is, if you're running a batch service, you might set N to be very low, either 1 or 2, because while you don't want to be interrupted and you don't want to have capacity unavailable, if there isn't enough capacity to process all your jobs, they'll just wait in the queue until EC2 Fleet automatically replaces those instances on your behalf. So it's less of a real-time scenario and more of a asynchronous batch processing. On the other side of the spectrum, you might be hosting your stateless web service on spot instances. And so while you obviously want to achieve very low prices just to improve the economics for your application, the most important thing when you're running a web service or a website is that the website doesn't go away. And so you might set N to be equal to something along the lines of 4 or 5 or even up to maybe 10 different instance types in order to diversify and spread across multiple instance types to minimize the amount of capacity that you might lose at any one point in time. And so the lowest price times N, as I say, is almost certainly the one you should be exploring and allows you to balance your own cost and availability. Until the recent launch of lowest price times N, the number one way customers used to deploy with Spot was using Diversified. Diversified still works really well for large-scale fleets where you're trying to achieve rapid scale. Diversified is going to go out and automatically deploy across all of the options that you provided it, assuming they're below the maximum price you're willing to pay and below the on-demand price. And so the whole idea of using Diversified is to spread and put as few of your eggs in each basket as possible to minimize the impact of any interruption while maximize the speed in which we're able to go out and get your capacity. Both are fine options, but as I say, if you've been using Fleet for a long time, do go back and explore lowest price times N. I think it's a great opportunity for customers to balance their own cost and availability needs. And if you like the diversified pattern, you could just set N to be 50, which will then behave in almost an identical pattern to the diversified option. For on-demand, the strategies are a little bit different because unlike Spot, where we're actually trying to deploy across multiple capacity pools to minimize the impact of an interruption, obviously for on-demand instances, you don't get interrupted. Once you have it, it's yours until you turn it back off again. So for on-demand, we offer lowest price and the on-demand prioritized list. Lowest price just finds the single cheapest option that you've defined and deploys capacity there. Lowest price is really useful for customers that don't care at all about the instance they launch. They just want to get the cheapest instances or cheapest cores and don't care about the order in which we do it so long as we start with the cheapest. I'm very happy that we've recently launched on-demand prioritized list because this is a very common feature request from the moment we launched EC2 Fleet of customers saying, well, I don't always want you to pick the cheapest price based on on-demand pricing. So as an example, the C5 instance type is cheaper than C4 per vCPU. But if you're a customer that has C4 reserved instances, you might actually prefer that we first try and launch your on-demand capacity using C4 instances. And so on-demand prioritized lists puts 100% of the control in the order in which we attempt to fulfill your on-demand capacity in your hands. And so you decide, try this one first, this one second, this one third, and that's exactly the order we're going to follow. We'll try and fulfill all of your capacity in your number one priority, and only if we aren't able to fill all of your capacity in your number one priority will we move on to your second priority and your third, and so on and so forth. And so just to reiterate the key benefits of EC2 Fleet, we're giving you fast access to capacity spanning multiple instance types and business models. We're putting the ability to optimize price, performance, and availability in your hands. And finally, we allow you to customize how you scale and how you use this tool based on your specific application. So you can customize the instance weights, you can customize the strategy, you can customize how much of the capacity should be filled using on-demand or spot instances. And one final thing I wanted to mention before I deal with some common questions and hand over to Chad are some of the prerequisites for EC2 Fleet. And really the one prerequisite I wanted to talk about was launch templates. Launch templates was launched at reInvent in 2017 and is in a tool that's designed to make it easier to launch capacity across multiple APIs and provide consistency across those services. It's easier to manage permissions because you now have a central place where you store everything that's required to launch your instances. And then you can decide whether the user has permission to use the launch template or even go a step further and put fine-grained permissions on what within the launch template customers can actually use and what they can modify. So you might say, as an example, here's the VPC, the subnets that we want to launch into. None of that can be changed. But when you're using the launch template, your users could potentially override the instance type, as an example. So it gives you an easy way to manage permissions and control how people use AWS in your account. It's much easier to propagate updates as well. So for anyone who's ever thought, I need to update an AMI and then go speak to 10 developers and make sure they all update to leverage the latest AMI, Launch Templates is for you. What you can do is you can have everyone refer to the latest version of a launch template. And then as an administrator, you can go and update that launch template and change the AMI or change the subnets or really change anything you want. And that will automatically propagate to anyone using the latest version of the launch template. And then finally, because now you don't need to learn the semantics of different APIs that launch EC2 like autoscaling and run instances and fleet, you can just focus on learning the new EC2 services rather than semantics of how to do the same things across different APIs. So launch templates is a prerequisite for EC2 Fleet, something to be aware of. If you haven't already started using launch templates, I'd encourage you to do it. They are totally free, and it's just an opportunity to simplify the way you provision capacity. So I wanted to quickly address some of the common questions before we go to a demo. And then obviously we'll come back and address any of the ones that we haven't already addressed in questions you've been sending through. So first and foremost, what's the difference between Spot Fleet and EC2 Fleet? The answer to that is functionally nothing. They are different APIs that do the same thing. When we added support for on-demand instances, we launched EC2 Fleet so that if you wanted to leverage this functionality only for on-demand instances, you wouldn't have to interact with an API called Spot Fleet. But aside from that, it's the same functionality. If you're using Spot Fleet, there is no reason to migrate to EC2 Fleet whatsoever. If you're getting started today, I'd obviously encourage you to explore EC2 Fleet as an API. So does this work with EC2 autoscaling groups is another very common question. The answer to that is right now, no. When we launched EC2 Fleet, we also made an announcement that we are going to integrate this functionality into EC2 autoscaling groups. So that's absolutely still something we are working on. Keep an eye out for that coming later this year. Does EC2 Fleet use my RIs? The answer to that is yes, if EC2 Fleet launches an instance that matches an RI that you have running. So you can now obviously use on-demand prioritized lists to explicitly tell Fleet what instances to launch. But what Fleet doesn't do today, just to be clear, is we won't search your environment and find unused RIs and launch those instances. It's obviously something that customers have asked us for, so keep an eye out, but it's not something that EC2 Fleet does today. And then finally, how much does EC2 Fleet cost? It's absolutely free. You just pay for the underlying resources that EC2 Fleet launches on your behalf. But the actual EC2 Fleet service comes at no additional charge. And so with that, I'm going to hand over to Chad to take us on some demos.
All right, thanks, Boyd. So what I'm going to do here is do a couple of demos, three to be exact. And what I'd like to do is kind of walk through the three different scenarios that Boyd covered, which is essentially the ability to use EC2 Fleet to turbo boost using Spot instances. The second is to use EC2 Fleet, to set it up to give the ability to do sort of a million core scale environment, and at the same time using multiple on-demand instance types to fulfill that scale requirement. And then the third is being able to scale and use something besides just raw number of instances to request my capacity. So as Boyd mentioned, you can assign weights to your different instance types as you request capacity. And so in this case, we're going to use virtual CPUs to define how we'd like to request our target capacity. So I've published these demos in a GitHub repo. We'll link this GitHub repo at the end of the presentation for you to browse yourself. But this is published in a GitHub repo under a directory called EC2 Fleet in the EC2 Spot Labs GitHub repo. I've just got some basic steps here that I will follow. So also as Boyd mentioned, a fundamental requirement for using EC2 Fleet is to use EC2 launch templates, right? So launch templates are very powerful. They allow you to templatize common requirements that you need to request capacity, EC2 capacity. And so the first thing we'll do is to create a launch template. And so I've got a launch template, a very simple one here defined that we will first create. That'll be the baseline for the demos for requesting the EC2 fleets. And so what I've done here is I've taken advantage of the ability to stash my AMI ID, right? This is something that is common no matter how I'm asking for capacity. I'm always asking for a specific AMI ID. And so rather than having to stash that in various configs for requesting capacity, I can templatize that in my launch template so that everything moving forward will use this AMI ID. And then as I create new versions of my launch templates, I can simply update my AMI ID in the different versions, and that way the various resources that are requesting capacity can reference either the latest or the default launch template version, which will in turn allow me to update my AMI IDs very easily. And the other thing I'm doing in my launch template is to provide tags to the various instances that are being deployed. So this is sort of a way for me to standardize my tagging strategy so that every resource that I launch through my launch templates has standardized tagging. So let's go ahead and do this. So we're going to do everything from the CLI. So the first thing we're going to do is we're going to essentially create my launch template from the CLI, and we'll do this here, right? So I've basically said, hey, please create this launch template based on this JSON config that I've just specified. So if I head back to my EC2 console and look in my launch template in my EC2 console under launch templates, and I refresh, you can see I now have a launch template called EC2 Fleet. So this is the one that I just made, and it gives me information about what is stored, what configuration parameters are stored in my launch template. So you can see there's a lot of things I can store. A very other common thing would be security groups and key pair names, things that are very common to my launching requirements. But in this case, I'm just primarily using it for the AMI ID. All right, so let's head back here. So the next thing we're going to do is we're going to go through this first demo scenario, which is to turbo boost my EC2 fleet with Spot, right? And we're going to use this configuration for my EC2 fleet, which is right here. So let's kind of walk through what I've done in this configuration. So I'll start at the bottom, actually. In this case, what I'm starting with is a request for a total target capacity of 5. And I've said all of that target capacity should be on demand to begin with. So when I first launched this this EC2 fleet, I'm basically saying I'm going to start with my on-demand capacity. All of my capacity is going to be on demand, and I'm going to ask for 5 of those. However, everything beyond that initial 5, I'm going to launch out of my default target capacity type, which I've defined as Spot. And I'm setting my initial Spot target capacity to 0. All right, so this means I'm starting with 5. If I grow my EC2 fleet request in terms of scaling up, I want all that scale to come out of Spot instances. So heading back up, I've also told my EC2 fleet that my allocation strategy for requesting my Spot instances is going to be diversified, and I've defined also the interruption behavior to be terminate. All right, so heading back down here underneath my launch template configs within my EC2 fleet request, here's where things get very powerful. So first thing I've done is I'm referencing this newly created EC2 Fleet launch template that I made, right? So I'm saying, please use this launch template as the baseline for my requirements for my configuration for my EC2 Fleet request. And I'm also referencing the first version. Since I just created it, it has version 1. Here it gets even more powerful. So in the override section, I can actually sort of append multiple configurations to my EC2 Fleet requests. In this case, I'm taking advantage of defining multiple instance types and multiple subnets that EC2 Fleet can use to pull from my capacity, right? So what I'm saying is I'm able to use C3 larges in this AZ. I'm able to use C3 larges in this AZ. So I've got 2 different AZs for C3 larges. Likewise, I'm also saying C4 large can go into these 2 subnets or these 2 AZs, and C5 large can go into these 2 subnets or these 2 AZs, since subnets are a direct mapping to availability zones. So essentially what I've done here is I've defined 6 different pools of capacity that I can pull from for my scaling up with my spot instance requests. And then I'm also taking advantage of tagging my actual EC2 Fleet requests themselves right here in the configuration. And then finally, I've done a couple more things. I'm requesting that my EC2 Fleet request is in maintain mode. So that means if any of my spot instances are interrupted, I would like for them to be replaced by EC2 Fleet automatically. And likewise, if any of my instances become unhealthy, if they crash and fail EC2 health checks, EC2 Fleet will detect that and they will be replaced automatically by EC2 Fleet as well. All right, so let's go ahead and launch this EC2 Fleet request based on this, this EC2 Fleet config. So we'll head back to our CLI. All right, so what we've done here is we've put a request in for an EC2 Fleet. I'm going to stash my EC2 Fleet request in an environment variable so I can easily reference it later in my CLI options here. So I've put my request in, and the first thing I'd like to do is I just like to describe the fleet itself to see, how is it doing in its request. So I'm going to go ahead and describe that fleet request. You can see it's been submitted. It has all my different instance types and subnet options in my overrides. It's got my fulfilled capacity, which is 5. I asked for 5, remember, in the config, and it's fulfilled those, and it's got all of my configurations basically stashed in it. So the next thing I can do is I can actually describe the EC2 Fleet history here. So let's go ahead and do that and see, the process of how it's spinning up my instances. Right, so we can see EC2 Fleet has done its job. It has launched my 5 instances that I've requested. You can see I've got 5 instances here that are all in the launch state. I've got my instance IDs. You can see that it's launched them in on-demand capacity and in availability zone US East 1A. So if I head back over to the console and I just take a look at my list of my instances, here they are. So I've got my 5 instances that I've just requested. They are all C5 larges because EC2 Fleet pulled from the cheapest of the options that I gave it to use in terms of capacity. And you can see the life cycle is all set as normal, which indicates these are on-demand instances. All right, so we've spun this up and everything's up and running. Now it's time to turbo boost our EC2 Fleet request. So what we're going to do is we're going to say, hey, EC2 Fleet, I would like to change my target capacity from 5 to 20. So let's do that now. Right? So it said, come back with a return value of true, which means it has accepted our request for that. And remember, if we go back and we look at the actual config, we said everything that we're going to use to scale is going to be of type spot. So let's go back and describe our EC2 Fleet request one more time. Fleet history. Right, so we can see that our fleet is in a change state where essentially it's recognized that we've asked for additional capacity, and so what it's doing is it's going to now in turn put in the spot instance request to handle the change in capacity request here. So we've got modify request received, requested target capacity of 20. So it's been a successful modification. And so what we'll see here is we'll start to see spot instances being used to fulfill the additional request in target capacity. So if I head back to my console and I do a refresh, we'll see that, yep, in fact, we've got our 15 additional instances that are being launched. They're being launched as spot instances, and they're being used to turbo boost our EC2 Fleet Request. So now we've got a nice scale happening on spot instances to supplement our on-demand capacity that we initially started with. So we can see we've now got the 20 instances that are running in our EC2 Fleet Request, 5 on-demand and 15 spot, and they've all been fulfilled here. And you can see that that EC2 Fleet did a great job of diversifying my spot instance requests across instance types as well as across availability zones. Again, this strategy I'm using to help diversify my spot requests to achieve high availability in my spot requests. So let's head back here. So our next pattern is going to be scaling to, setting ourselves up to be able to scale to the million core scale, and we're also setting ourselves up to be able to tap into multiple on-demand EC2 instance types. So before I do this, let me just clean up and terminate my EC2 Fleet Request that we just set up so that we don't have a cluttered environment. All right, so we've got an acknowledgement that we've requested to delete our initial EC2 Fleet Request. So let's look at what our configuration is for million core scale and on-demand backup. So this one's actually a little bit simpler, right? So what we've got here is we've got a configuration for our EC2 Fleet, which is very simple. We're saying, hey, I would like to use these 3 instance types for my on-demand capacity. Now, because EC2 Fleet is, in this case, is going to pull from the cheapest, I'm setting my priority to be C5 larges. But we're giving EC2 Fleet the ability to also pull from C4 large and C3 large so that it can properly fulfill our target capacity requirements in the case that it doesn't have enough of C5s in this subnet to fulfill my request, right? So it's going to default to C5 large in this case because it's the cheapest. It's going to use this subnet, but if it needs to tap into these additional pools of capacity to fulfill my target capacity request, it can do that. And I've set all of my requests for target capacity equal to on-demand. So the rest of this is very similar to the previous request that we made. So let's go ahead and launch this request here, right? So very similar to what we just did, we're going to create an EC2 Fleet Request with this configuration. So we've got our EC2 Fleet IDs. So I'm just going to stash this again into an environment variable so that I can reference it through later configs. So let's go ahead and take a look to see how our EC2 Fleet request is going. We'll just describe the fleet ID here again. So you can see I've got, in this case, my 3 different instance types defined here. I'm still referencing the launch template that we made initially. I'm also asking initially for a target capacity of 5. Again, the on-demand component of my EC2 Fleet config is a static amount, and I've also told my EC2 Fleet that it can again tap into multiple capacity pools to fulfill my target capacity request. So next, let's go ahead and describe my EC2 Fleet history. Okay, so this EC2 Fleet request has also been fulfilled. This particular request was able to fulfill my target capacity of 5 by using C5s in availability zone US East 1B. So if I go look at my console, we can see that I've now got 5 instances that are in the running state that are all associated with this EC2 Fleet ID that we just created. So we've got this request has been fulfilled. It's using on demand for fulfilling this this capacity because that's what I've asked it to do. If it needed to tap into multiple pools to fulfill my on-demand capacity, it can do so because I've allowed it to in my request config. So let's go ahead and clean this demo up here, and then we'll head into the third demo here. So I'm just going to go ahead and say delete this fleet request. All right, so now it is actively deleting my EC2 Fleet request. So let's jump into the third demo here, the third design, which is, let's scale on something that is relevant to our application, right? In this case, our application is going to scale on number of vCPUs. So let's look at what this looks like inside of my EC2 Fleet config. So in this case, you'll see in my override section, I've actually added a new parameter, which is called weighted capacity. In this case, what I've done is I've weighted my capacity equal to the number of vCPUs that each instance type is providing. So in this case, I've said I'm able to use R4 for extra larges, and they're going to provide to me 16 weights, which means in my case 16 vCPUs. So I've also said I'm able to use C5 2 extra larges, and those happen to provide 8 vCPUs, so I'm going to assign them a weight of 8. And then finally, I've also said I'm able to use M5 extra larges, and those are going to provide me a weight of 4, right? So I'm now able to mix and match these instance types. If you think back to that slide Boyd showed where you've got the different instance types and sizes filling up your bucket, saying, I need a total amount of capacity, but feel free to mix and match each of these as you're able to fulfill my capacity. In this case, now when I request my target capacity, which I'm setting at 1,000, what I'm saying is I need 1,000 vCPUs, right? I'm saying pull from these instance types and these AZs to meet my 1,000 vCPU request. And I'm doing all of this with Spot here as well, since I'm setting my default target capacity equal to Spot. So let's go ahead and spin this one up and take a look at how it looks from fulfillment perspective. So let's go ahead and spin this up. All right, so I've got my fleet ID. Let me stash this in my environment variable. Okay, so again, remember, I have now told EC2 Fleet I'm after vCPUs. And so its job is to go out and find those vCPUs for me, and it's going to use the weights that I provided in the config to fulfill my target capacity request. So let's take a look at the actual request itself, make sure that it has what I've asked for. Yep, so I've asked for 1,000 total target capacity. I've asked all of that to be in Spot because my default target capacity type is Spot, and as you can see, it has grabbed our config and assigned the weights equal to the number of vCPUs in each of these particular instance types. So we'll just do this one more time to take a look at the request itself. And finally, what we'll do is we'll start to describe, oops, sorry, wrong one. We'll describe the fleet history to look at how it's fulfilling our target capacity. Okay, so you can see here that it's begun to fulfill my target capacity request, and it's using a nice diversified list of instances and AZs. So I've got an M5 extra large, I've got an R4 extra large. These are in different availability zones. So you can see it's mixing and matching the instance types as it needs to fulfill my target capacity request. So let's go back to the console and take a look at how this looks from a fulfillment perspective. Okay, so you can see I've got a ton of instances spinning up. Looks like I'm, if I filter by running, like I've got about 115 instances that are being spun up. You can see these are on spot, and you can see a very nice diversification happening here where I've got a mix of instance types as well as availability zones, and these are all fulfilling various components of my target capacity, because again, each of these are providing the weights that I assigned to each of these instance types to meet my total target capacity request. And so that's how you would do it, right? It's very simple to do. If your application was, your app needed memory versus vCPUs, for example, you could assign these weights based on the amount of memory each of the instance types is providing to your particular application. Or if you're using containers, maybe how many containers can each of these instance types hold as I deploy containers onto these instances. So that's pretty much it. Boyd, do you have anything you would like to add, color commentary to this demo here that before I turn it back over to you?
No, nothing more from me, Chad. Thank you very much for taking the time today. If you have any remaining questions, please send them through and we'll start answering them shortly.